Okay, let us continue with problems on steady state error. So now we will see what is steady state error of a system where it's a non-unity feedback system. So the unity in the feedback path, we don't have HFS as 1, so it is a non-unity feedback. In such case, how do we actually find out the steady state error? So in the previous videos we have seen how do we find out the steady state error of a unity feedback system where the gain was given by 1 over Ka Kp. So these were the table what we obtained for type 0, type 1, type 2 system with the different type of inputs. So in all these cases the consideration was HFS was equal to 1. It's a unity feedback system. So in case of non-unity feedback system, we cannot use that error coefficients like Kp, Kv, Ks. So let us try to find out how do we get the steady state error when the feedback system is non-unity. Again, let us go with the very basic of error of a system is nothing but R of t minus C of t, that is desired output minus the actual output. So if I take Laplace of this, EFS is nothing but RFS minus CFS. So again now I can take out this RFS as common here. So this will become 1 minus CFS by RFS. So now we know that this CFS by RFS is the transfer function. So now I can write EFS, the error signal, is nothing but RFS multiplied by 1 minus the transfer function, 1 minus the transfer function. This is what is the error. What is actually the steady state error? The steady state error is nothing but limit of t tending to infinity with E of t. Using final value theorem, I can write it as limit of s tending to 0 s into EFS. Since I know what is EFS for a non-unity feedback system, I can write this in place of EFS, I can write it as RFS into so and so. So now therefore ESS, it's not EFS, ESS means steady state error. This is steady state error. Steady state error is limit of s tending to 0, s tending to 0, s into EFS is now RFS multiplied by 1 minus the transfer function, 1 minus the transfer function. So in case of a non-unity feedback system, the steady state error ESS is given by limit of s tending to 0, s into whatever is the input that you are considering, you can consider 1 minus transfer function, 1 minus the transfer function. So let us take up a few examples and try to find out how do we estimate the steady state error in case of a non-unity feedback system. So let us take few examples. Okay, this is one such example where we have GFS as this block and HFS is now, you can see it's a non-unity feedback system. So now ESS, we know that it's equal to limit of s tending to 0, s into RFS 1 minus TFS, 1 minus TFS. So now before we proceed, we need to find what is the transfer function of this. So transfer function of this is nothing but CFS by RFS, which is nothing but GFS by 1 plus GFS into HFS, which we can, because we know what is GFS and HFS, I can write it as 5 by s plus 4 divided by 1 plus 5 by s plus 4 into HFS is 6 by s plus 2. So we may have to simplify all these things. So maybe those who have done sufficient problems on this, it's not like a practice. So if you got the concept of this, so I can write the transfer function of this system as, you can retain this, whatever GFS you have, you can just retain it as it is s plus 4. So there will be one more term that is that will be plus or minus depending on this. If it is negative feedback, it will be plus. So plus of, it is the numerator of GFS multiplied by the HFS. HFS is actually 6 by S plus 2, 6 by S plus 2. So now I can simplify this. So take the LCM. So this will become 5 by S plus 4 into S plus 2 plus 30, okay, whole divided by S plus 2. So this S plus 2 will go on top. So transfer function, of course, upon doing the calculation for this, you will get the same thing here. So it can be 5 into S plus 2 divided by, okay, let me just put it in the same form, because this is not required to multiply all those things. I can write it as S plus 4 into S plus 2 plus 30. This is my transfer function. So what you are supposed to do here is, so to find ESS, what I do is, this is limit of S tending to 0, S into, what is RFS? RFS is actually, so now if you find RFS for this, it's actually 3 by S, because you have 3 into step input. It is 3 by S. So this will become 3 by S into 1 minus TFS. So TFS is now 5 into S plus 2 by S plus 4 into S plus 2 plus 30. So this is my transfer function. Now this S and S will go off. Then you have this 3. Then you apply the limit of S tending to 0. This will become 0. This will also 0. This is also 0. So now you end up with ESS as equal to 3 multiplied by 1 minus 5 into 2, 10 by this is 2 4s are 8 plus 30. So if you calculate that value, this comes out to be 3 multiplied by 1 minus 10 by 38. So it is now 2.21 is my error. So this is what is ESS for this system. I hope you got it. So let us recap it again. Since it's a non-unity feedback system, the ESS of such a non-unity feedback system is given by S into RFS into 1 minus TFS. So of course you are applying the limit of S tending to 0. That's what we saw here in the derivation. Now since this is the block diagram given, so I need to find the transfer function of this. Even upon simplifying, you'll get the same thing here. So this is what I'm having. So this happens to be 5 into S plus 2 by S plus 4 into S plus 2 plus 30. Substituting this as TFS over here, it is 1 minus TFS, and of course it is S into 3 by S, because this is a step signal of amplitude 3. So upon simplifying, I got an error of 2.21. So 2.21. So this is a finite error for a step input. Now let us see this second problem. Okay, here also it's a non-unity feedback system, because in HFS it's not 1. Now we are asked to find what is ESS for K. Here K is 0.4 and GPFS is 1. So this is GPFS. If it is 1 and this is 0.4, they are asking what is ESS for an input of unit step input. So now we know that for a non-unity feedback system, the ESS is given by limit of S tending to 0, S into RFS into 1 minus TFS. So before we proceed, let us find out what is TFS. So TFS is actually equal to GPFS multiplied by K into S s plus 2 plus k into s plus 3. This will of course it will have, so by s plus 0.1. so this happens to be the overall transfer function is okay, sorry for the disturbance. It is now GP of s into k into s plus 0.1 divided by s into s plus 2 into s plus 0.1 plus k into s plus 3. So this is my transfer function. In the first case they are given GP of s as 1 and k is 0.4. so with R of s as 1 over s, so ESS now comes out to be limit of s tending to 0 s into 1 over s 1 minus, so what will be this? This is 1, this is 0.4 and this is 0.1 divided by, okay, this will totally become 0, this will become 0.4 into 3, correct? Because this as s tends to 0, this entire term becomes 0 here, so this will become 0, k into of course k is now 0.4, this is this. So can we find what is ESS here? Okay, we are already applied, this will go off and this is we already applied, so ESS is now equal to, okay, 1 minus it is 0.4 into 0.1 divided by 0.4 into 3. 0.4 into 3. This happens to be, did I made, okay, this happens to be 0.7. This is ESS, which is 0.7 for this particular problem. See here, so we actually found what is TFS for this. So it was found out to be, we actually reduced this, and of course ultimately we multiplied with GPFS. So this is GPFS multiplied by because this even you can multiply it later also, it doesn't matter much. So it is now, this is the overall transfer function. For this transfer function you are applying the limit of s tends to 0. So wherever s is there, put it as 0. This entire term becomes 0. This is k into 3. That's what is k into 3. Here it is k into 1 into 0.1. That's what is this 0.4 into 0.1. This is ESS. And then we are asked to find what is GP of s to have a ESS of 0. So now the question is, so let us have this ESS as 0. So let us now take this. So here we had it as 1. For GP of s is equal to 1, we had a ESS of 0.3. Now what is ESS asked for? ESS need to be 0. So for this, shall I equate this entire equation to 0? 0 is equal to, of course, limit of s tending to 0. This is already applied, s into 1 over s. It is now 1 minus. Let me retain this GP of s as it is. It is GP of s into 0.4 into 0.1 by 0.4 into 3. Now I need to find what is GP of s. So this will anyhow go. This has been already applied. So I can equate 0 alpha equals to 1 minus open the parenthesis alpha a into 0.4 into 0.1 divided by 0.4 into 3 close shift cal. Now GP of s happens to be 30. If you multiply of course, if you have a GPFS is equal to 30, the ESS will be equal to 0. ESS will be equal to 0. So in the previous example, you might have seen that when GPFS is equal to 1, you had an error of 0. You have a steady state error of 0.7. To make this 0.7 as 0, we can actually start increasing this value. When this becomes 30, the steady state error becomes 0 for a unit step input. So this way we can able to fine tune the system to have a error of 0. So with the GPFS is equal to 1 and of course k is equal to 0.4, we had some error, steady state error. That error can be minimized to 0 for the same step input with the same value of k as 0.4. If the value of GPFS becomes 30, then the system steady state error will be 0. Okay, let us see what is this. Okay, here HFS is given as 1. It's a unity feedback system. So in case of a unity feedback system, of course this is GFS. So we are asked to find what is ESS for U of t and t. That is ESS for this particular input is 1 over 1 plus Kp plus 1 over Kv. So for this we need to find what is Kp, Kvs. So what is Kp? This is limit of s tending to 0 GFS into HFS. Of course HFS is 1. So if you apply that limit of s tending to 0, okay, in this case it is limit of s tending to 0, 10 by s square plus 14s plus 50. When you apply that limit of s to 0, this will become 10 by 50. This will go off, it is 1 by 5. So Kp is now 0.2. So it is now 1 over 1.2. So it is. So this is about Kp value, and coming to Kv, which is nothing but limit of s tending to 0 s into GFS HFS. So it is now limit of s tending to 0 s into 10 divided by s square plus 14s plus 50. When you apply that limit, this becomes 0. See here, this will become, because this is 0 into something and here this is 50. 0 by 50 is 0. So it is now plus 1 over 0. So the ESS is infinite. ESS is infinite. Because this is a type 1 system, you have an input of ramp which will end up with the ESS of infinity. So that's what we saw in one of the tables. So in the initial classes, in the initial video, you can see it is type 0. If you have this, it's a infinite ESS. And of course, when you have a U of t, that step input, you had a finite error which was 1 over 1.2. So this doesn't have any meaning because you have a error due to ramp input as infinite. So overall it is infinite error. Okay, let us see this. This is a very interesting one, a conceptual circuit. What example? So we are asked to, so with the value of k as 1 for a unit step input, this is the response of a system having some GFS. So we don't know what is GFS is. We are asked to find the value of k to have a ESS of 0. So actually the input that is applied is unit step, but output is settling somewhere here, which is at 0.8. You have a ESS of 0.2. Can you see? This is 0.8, this is 1. So this error is actually 0.2. So now how do we find this one now? How do we find the value of k so that this goes there? Suppose what is intended is you have to change the value of k such that this is my expected value. So this should settle down here. This should settle down here. So there should not be any error here. There should not be any error here. Now, actually we know that when you have an output something like this, now whatever output you have, so with this k is equal to 1, you have this as the output. Now this 0.8 should become 1. So you have a 0.8 as the output. Now that 0.8 is certainly multiplied by this k, so that should be equal to 1. So now by multiplying what with 0.8, you will get it as 1. So now what we have is k is now equal to 1 by 0.8. So now what is 0.8? 0.8 inverse is 1.25. So if you make the value of k as 1.25, if this is equal to 1.25, the error will be 0, meaning it will settle at 1. It will settle at 1. So this is the value of k will be 1.25, so that the error is 0. Steady state error is 0. Okay, likewise, of course, here you are not using any equations, but purely conceptual. So if you multiply this overall thing by 1.25, you can see 1.25 into 0.8 is 1. So you can just do that. So 1.25 multiplied by 0.8 is 1. So whatever 0.8 you have will go to 1. Suppose if you are multiplying this with 1.25, which is a k value. So here no need to use KP, KVs and all those stuff. Even without knowing GFS, you can able to predict, or you can able to find out what is the value of k, so that it ends with a ESS of 0. Thank you.